Okay, good morning. Nice to see you again. Today we will we will continue with mapping architecture to design. Last week we have seen how we could map to object-oriented design alternatives. Last week it was Monday, right? There we considered, for example, we gave as an example an adaptability. If the architecture needs to be adaptable, it has consequences on how you map to design. Okay? If everything should be runtime adaptable, it meant that we need to map every architectural concept component to a class and basically use the part of relation. Okay? Today I will talk about application frameworks. Let's put the mechanism. Sorry. I'm sorry. Application frameworks. So this is the which focuses actually on reuse of the architecture, the reusable design of the architecture. We could have, so this is the first alternative. We have the architecture. This is designed after a thorough problem analysis and domain analysis. We have even seen that we could have the architecture of the sub components of each of these components. Then we have to, at some time we have to map this to design. We could map to a fixed object-oriented design, okay, which we call also, that we will see later on, that we call module view or implementation view, also called. That's the first alternative. Okay. Another alternative, well, in this alternative we have seen that we could also look at different alternatives with respect to quality. Okay, the quality shapes your architecture, shapes your design. Based on what kind of quality we want, this will be different and that one too. Okay. A second alternative is to map the architecture to an application framework. What's the definition of application framework? Reusable. So reuse is a key here. Semi-complete. It's not complete design, but it's just half. Application that can be specialized. It is not completed, but you can specialize it to produce more custom applications. Or so a set of classes that embodies an abstract design for solutions to a family of related problems. Okay. So here you focus, you try to actually take the architecture and you would like to make it reusable so that you can develop multiple products. Okay. Application framework, object-oriented application framework. If we compare a framework with respect to a single application, we see that the level of abstraction of frameworks is higher because in object-oriented frameworks, of application frameworks in general, we focus not on single application but multiple applications. Okay. So therefore the applications should be, the framework should be reusable and cover also, take into account all the requirements of the different products. Consequently, it requires also more resources to develop a framework. It is easier to develop one design than a framework which needs to cover, to meet different type of products. A framework is incomplete with respect to a customized application, because it needs to be completed, to specialized before you can use it. And frameworks must be explicitly designed for flexibility, extensibility, completeness, and ease of use. So you have if you take the framework, you should be able to easily add, update, specialize it so that to meet your own concerns. Object-oriented frameworks, it's very known, is thus a reusable semi-complete application implemented through a set of classes and their collaborations. This is the framework, it's in the abstract sense, and the users of the framework, they just complete or extend the framework to define a custom application. Okay? There are fixed parts and variable parts in object-oriented framework. The fixed parts are called frozen spots. They capture actually the commonality of the products that you do focus on. The hot spots define the variant parts. There you have to check in the framework what is adaptable. And so, for example, this part is common. There are some parts which are hot spots. And the hooks, the so-called hooks, are the specific ways in which a framework can be customized. For example, subclassing parameterization define hooks. Okay? This is, in abstract sense, it's a hook, and you specialize the framework at these hooks. So the framework defines the common parts, which are fixed, you cannot change. Plus, it has some hooks, the hotspots, where you can specialize the framework. This is from the front cover or from the communication of the ACM from Fayyad Schmidt about object-oriented application frameworks, actually nicely visualizing what application framework is. A part of the framework has been built, but the other part still needs to be completed. Okay? Semi-complete application. Why? Because you don't focus on one application but multiple applications. Okay? So you don't fix the implementation, the design, but you just provide the hotspots and the hooks so that the framework users can themselves adapt the framework and define their own applications. There are different roles of the framework. Framework developers, framework users, and framework maintainers. Framework developers are the persons who develop the framework based on actually the architectural design. So if you have the architectural design, you can map to a framework based on domain-driven architecture. Framework users, also called framework clients, are the application developers. They use the framework, they reuse the framework to develop specific applications. And framework maintainers is the group of persons who refine and redevelop the framework to meet new requirements. So the framework itself is also not static. Okay? You might need to adapt the framework itself so that it becomes flexible, or it can be usable for developing new kind of applications. So then we get this choice. So we have the architecture. First we had this fixed, but now we map to an object-oriented framework where this is not complete but semi-complete, and where we deliberately, explicitly define the hotspots in the framework. That is the variant parts in the frameworks, where we also define how to adapt the framework. Okay. Then we get here, in this case, this is the atomic transaction system architecture, and this is object-oriented transaction system framework, consisting of set of classes which can be reused, extended to define specific transaction system applications. So we don't have a single transaction system, but multiple transaction systems can be derived from the framework. What's the key motivation here? So it's reuse. If you take, if you look closer at the concept of reuse, so what's that? Is the process of creating software systems by using existing functionality or by combining predefined software components. And object-oriented frameworks, application frameworks, aim to provide gross-level reuse by providing reusable semi-complete applications. The goal is to reduce the cost and improve the quality of software. If we have a framework, reusable framework, the idea is that we can more quickly develop applications, since the quality of the framework, the components of the framework, the classes, has been tested, so the application will be also of high quality. And of course, altogether, it will reduce the cost because we don't need to develop a complete application from scratch. We just take the framework and then specialize the framework. This is actually so in reuse we have also the concept of product line engineering. This was before product line engineering actually. If we have time later on, I will also explain product line engineering concept. We'll see. So where we define the complete life cycles, the two life cycles, where we first do domain engineering, develop the reference architecture, and where we have a process of application engineering, where we customize the architecture. If you look at reuse, there are several reuse methods. As I said, actually one of the latest cross-level reuse approaches is software product line engineering. Before that, we can identify these techniques: object-oriented programming language mechanisms, information hiding, abstraction, inheritance, polymorphism. They all support reuse. Okay? And in particular, of course, inheritance. You have abstract class, you subclass, so you can reuse the existing class. Class libraries, including classes that can be reused or customized. It's not necessarily a framework, it's just a set of classes that you can just use. Software components is a higher abstraction level than objects, as we have seen before. Components with standard provides and requires interfaces that enable interaction with each other, that you can compose. Design patterns, very important in software reuse. Lots of research has been done on that, and many patterns have been proposed. Pattern, generic solution to recurring problems. We have object-oriented design patterns. As we will see, also architectural design patterns. Application frameworks is the reusable semi-complete application, which we can customize further. The application frameworks are usually built using the design patterns. So actually, these object-oriented programming language mechanisms support design patterns. Design patterns are the best possible way to combine these object-oriented constructs for a given set of problems, and design patterns actually are used in application frameworks. Why? Because patterns themselves are also focusing on, for example, adaptability. Something should be adaptable, and as such this can be nicely applied in application frameworks. A further level of reuse is the concept of software product line engineering. This was a separate course here at Bilkent. There we have the multi-system scope development, where we develop applications using a common reference architecture, but also common core asset base. Okay. We look at class libraries, so let's look at in more detail. We had this set, you know this one in the course. Look at class libraries. It's a set of reusable classes, routines, example scientific software, the GUIs, a GUI class library or toolkit. And this represents actually the control logic. In class libraries, the user is responsible for defining, for implementing the control logic. Because, okay, they are actually kind of separate classes. If you look at application frameworks, the framework itself already defines the control logic. Okay? It's a framework about transaction system. The whole control logic is in the framework. Okay? But what you have to do is specialize at some point, extend, adapt. Okay? The user inserts application-specific code design in the hotspots. Okay? In class libraries, you define the control logic yourself. Here, the control logic is reused, but you just update, adapt the framework at the hotspots using the hooks. For example, hook methods. So we say this is an inversion of control. In application frameworks, we inverse the control logic. It's already provided, and you define the hotspots. Well, if we classify the frameworks, we can classify based on scope and based on the techniques that are used to extend these frameworks. We can have basically three types of frameworks: system infrastructure frameworks, middleware integration frameworks, and enterprise application frameworks. System infrastructure framework. For all of these, they are just semi-complete applications. In system infrastructure framework, if we look at the layer which we can generally define, we have a system layer, application layer, a system application framework, system infrastructure framework defines the framework at this level. Okay, so such as at the operating system level. Usually it's internally used. Okay. Middleware integration frameworks is used when you have to integrate several services, distributed applications and components, which could run on different platforms, different operating systems, different programming languages. And you could just define a common middleware, such as Corba or message-oriented middleware, which defines the services for distribution. Okay? The distribution logic, okay, which includes the directory services, name services, which can provide also additional services. Okay, like for communications. This is the middleware integration framework. The enterprise application framework is at the application level. They are just defined for application domains or business domains. They are relatively expensive to develop, but if you have it also at this level, the framework, it can provide you a substantial return on investment. What's the return on investment here? You develop a framework, you put lots of investment, upfront investment, and you get return on investment if you develop the specific applications. Okay. If you look at the distributed car dealer system case, which consists of a set of dealer nodes, and every dealer was layered in such a way. We had the applications, so where we have workshop, order processing, event used car management, stock management, accounting, other services, leasing, and system layer consists of transaction, control flow, etc. So what type of frameworks can we identify here? This is actually the top level deployment architecture. What type of frameworks can we identify here and where? We have system infrastructure frameworks here needed somewhere. Yes, no. Do we need it? The system infrastructure frameworks. Where's the system infrastructure framework? Where do we put? Normally, here. So then the question is, can we provide your system infrastructure framework? Actually, yes, right. And one example is transaction framework, right? But we could have also other, like control flow framework. So it's just like at the operating system level. It supports the applications, but also the transaction system supports applications at the operating system level, but still, so we can define it as a framework. Why? In particular, in this case, the case was that we needed more than one type of transaction system because of the needs of the different car dealers and different system requirements. So we had to be able to switch to different transaction protocols. So we can put this here. Middleware Integration Frameworks. Yes, no? How do these nodes communicate? We could have, right? We could put here a middleware layer, which can be a framework, right? Provide Corba. It's just example, one example. A Corba implementation. Application framework. Where's application frameworks? Here, right? Okay, so it's at this level. So we could have a framework for stock management. Okay, a semi-complete reusable application. It's clear? So this is the mapping from architecture to a framework. So we make such kind of decisions. We can classify application frameworks further based on the techniques that are used For that we can use two types. We can distinguish between two types of frameworks, the white box and the black box frameworks. White box refers to the white box reuse, where we can have just look into the code, we can just analyze and see it, and based on the code we can extend, adapt the code. For example, we can just view the classes. We can see the operations, the attributes. And so it's a white box. In black box, we don't have the look. We cannot look into the internal details. We can usually just the external interface. For that, basically, we have to compose these components. The code usually might require glue code. So white box, we can see the internal structure. Black box, we cannot see it. And based on that, we can actually distinguish between white box frameworks and black box frameworks. This is an example of the transaction system. We mapped it to a framework, atomic transaction system framework. One part consists of schedulers. We have accept handler. We can just, in the white box framework, we can see the classes, the operations, the attributes, and we can, for example, based on that, we can customize, adapt, extend the, for example, the scheduler, like we did here. This consists of decide, commit, abort, and what we do here is define a new subclass called locking scheduler, where we implement the operations decide, commit, and abort. Typically by also looking at the operations here, the default implementations here. So customization through inheritance from the base classes, and here we override predefined hook methods. To do this, to define the right implementation, we have to understand this. This is the overall view of where we map to the framework. Here we have the schedulers. At the top we have the abstract class universal scheduler. This forms just one part of the object-oriented frameworks. The universal scheduler consists of these 5 methods: read, decide, write, decide, commit, abort, commit, request. We can say they are like hook methods, and every subclass actually inherits from these methods, and it either inherits, so it reuses the methods, or it redefines. So this read decide means here like the basic two-phase locking scheduler subclasses from the universal scheduler, but here it redefines the operation. That's the hook methods. So clear so far? So we start with the whole problem analysis, domain analysis. We define the architecture. Then we decide to map to a framework. And framework can be either black box framework, white box framework. In this case, we have chosen for a white box framework, where we say that in order to use the framework, the users should see the code, the design, the details, so that they can extend the framework to define new transaction applications, like we did here. So the users here, for example, we could say, so user can just inherit from this universal scheduler class and then redefine the methods. Black box frameworks, we don't have the view on the internal details. We have just the requires provides interface, and the customization is basically through composition. But the framework can define the possible combinations So you don't have subclassing here, for example. It is easier. You just take set of components and you glue them together, integrate them, define glue code. It's easier to use than white box framework, but it's more difficult to develop. Okay. This is an example. It's the framework. We just want to actually instantiate the framework, and we have some components here about transaction manager, scheduler manager, recovery manager. What we just do is instantiate and then define it here. Okay, it's composed the product, and the overall framework defines the composition, integration of the components. Usually, frameworks can evolve from white box to black box frameworks. This is a white box framework. This is our initially defined framework. These are the parts which have been defined. Can be defined, for example, by users of the framework. After a while, we can just put this all together in one framework. Okay, where we have defined all the components, and in order to reuse the framework, you only need to instantiate and compose the application. Instantiate the components and compose the application. There are some requirements for frameworks. They should be complete with respect to the products that you want to develop. Of course, they should be flexible and extensible so that we can easily add and modify functionality. Understandable. In order to reuse the framework, of course, the user should be able to understand the frameworks, and this requires that the frameworks are well documented. The benefits: you get the result in long-term savings. Leverage domain experts' experience. You put just actually it starts already with domain-driven architecture design. You put the domain knowledge in the architecture, and if you map that to framework, you can reuse that. Promotes consistency and better integration across applications. It reduces maintenance and enhances productivity. You take the framework, you adapt, and the idea is that you can produce faster with higher quality. There are some disadvantages, liabilities, risks. The learning curve of a framework can be substantially high. Just take an example framework. In order to reuse that framework, it can take you a considerable amount of time. Okay. Programs can be harder to debug. Okay, the control logic is defined by the framework. It requires documentation, maintenance, and support, and very often lacks rigid methodology support. How to develop a framework. This is so there's a trade-off between the benefits and costs, so that you can decide whether you should or not map to a framework. Well, a short summary. Mapping architecture to design can be done in different ways. As such, leads to different architecture implementation alternatives. So based on quality, the quality actually shapes the architecture. So every alternative implementation, realization, will perform differently with respect to quality factors. And as an architect, you have to know both the quality and also the techniques to define these alternatives. Architecture can be mapped to a single application, single complete application, or if you need to reuse, you can map to an object-oriented framework, a reusable semi-complete application that can be customized for multiple applications. And as such, actually, the architecture is slowly then growing to a product line architecture. But product line engineering paradigm is broader than the concept of application frameworks. Any questions about this part? It's clear. Okay, then we break and then continue in 10 minutes.